My name is Davis, and through this tutorial, I'd like to talk about Docker Swarm and few of its capabilities. So I'll get started with a brief introduction of it, what monitoring tools we are using in order to visualize and see the utilization of the containers spawned on the cluster of nodes. And number three is elastic growth. Basically, as a number of requests to the containers increases, it should spawn more containers, and as the load on the containers decreases, it should decrease the number of containers. So yeah, let's get started. For a brief introduction to Docker Swarm, what Docker Swarm enables is creation of a service. A service is essentially an application or a task that is run as a container on a set of nodes, and these set of nodes are cluster of nodes. So there's usually a master and there's a worker nodes. So the master is which creates the services and schedules a job amongst the worker nodes. So it has three main features, capabilities. One is the load balancing. It load balances the request onto the containers effectively, using a round robin manner or so. And it, for doing this and for doing the service discovery part, it uses an ingress routing mesh or an ingress network. And so it has a built-in to achieve that, and I'll demonstrate that soon. And for the service discovery is essentially you run a service, say in this case you're running cadvisor on port 8000. All the nodes in your cluster will be aware that this service is run on port 8000 on a particular node, and this feature of service discovery is built in. It does not require a registrar application server which is discovering the services run. Second, it is resilient and scalable. That is, as the load increases, and this and the elastic growth will go hand in hand, as I'll show you. Now to monitor. Okay, now actually let me take a high level diagram of what I'm trying to achieve through this tutorial. So I will have a cluster of three nodes. There'll be a Docker Swarm master and Docker worker node 1 and worker node 2. These are the IPs of the nodes. And whenever I do a Docker Swarm init on the master, I'd create a ingress routing mesh and all this. Okay, so let me just show that to you. I'm going to advertise this address as my master and the worker. So this is the master node, and yeah. So for joining the server nodes, I will essentially now itself I can just show you what I mean by the ingress network. So you will see this swarm overlay network, which is the ingress network, right? So whenever, let's say I publish an application at port 80, through the ingress routing mesh, it is going to know that port 80 is on this node. So if I go to 192.33.12 port 80, it will still route it effectively to this node through the ingress routing mesh table. Now, yes, now let me have the cluster. So this is a token. The worker nodes are going to join using this token created by the master. So yeah, so now if I do docker node ls on my master, I'll see that I'm the leader and these two are my worker nodes, which is a cluster of nodes. Now to get on to the second aspect of thing, which is a monitoring aspect, where I'm going to use two tools, cadvisor and and visualizer, that is Manomax visualizer. So both the tools have its advantages and disadvantages, as you'll see in a second. So this particular application, the target port is 8080 and the published port is 9000. So if I go to any IP, essentially it could be the server, it could be the, okay, it's not yet come up. Okay. Oh, I guess let me just check if it's come up. It just started running. Okay. Okay, let me check the port number again. So I just ran this. It is running about for 20 seconds. Let me refresh the page. Okay, now it has come up. And yeah, you will see that visualizer is, so this is the visualizer container image, which is a monitoring tool. You will see I can filter the containers here, and I can see the visualizer is running on the manager, but I do not have, I know that the task is this is the ID, this is the running state, but I do not have any information of the utilization of the system or so, and this information is critical for scaling the number of nodes or the containers in the cluster. So let me now show you, this is a disadvantage of CAdvisor, but it gives a very simplistic view where my containers are running. So now let me show you CAdvisor, which is another monitoring application created by Google. So what this does is, so let me copy as a CAdvisor. Okay, I think it should, oh yeah, it's wonderful. See, you get these visualization of, okay, this it's gotten from this is the SHA 256, and this is all of it, all the information. So now I can go to any uh, so I believe I published port 8000 on it. So let me go to port 8000, right? And I am essentially seeing, so as you can see, I get to see the complete utilization of the system. I will see the Docker command, there's a utilization, and essentially the entire utilization of the system. This gives a very detailed view of the thing, of the utilization, and it's an API, so you can use these calls for later for your logging server. Now to get to the main crux of the tutorial, which is the elastic growth component, where to do that what I've done is, I have a diagram showing that. So essentially I'm running a client application, a client Python code, which is a UDP code, which on the worker nodes, and on the master node I will run a server Python code. And what this does is, for every container running, it'll give the CPU utilization to the master, and master examines it. If the CPU utilization is over a certain percentage, then the Docker Swarm, I'm going to scale the service that the particular application by, let's say, by 1, and then by 2, and then and so on. And if the load CPU utilization is decreased, that is, the load has decreased, then I will scale down the application. So let's see this now. So let me pull up the application, which is this is the application. It's essentially a shopping cart application, and it will only run on the worker nodes, that is node role, and on port 8080. So let me run this. Okay, so let me see if it is up. So this is the beauty of Visualizer API. So now it's running on this worker node. It does not really matter which, if I have the IP or not of the correct worker node, because of the service discovery aspect. It's built in. It has a built-in DNS also. That is the beauty of Docker Swarm, and it has a built-in load balancer too. Every node in the cluster runs this load balancer. I think it'll take a minute. Okay, now I think it's up. It's going to serve the request, which is a shopping cart application. Now if I go essentially to, I take this and I put 10 also, does not matter. It is still going to serve me the request. Okay, I think it'll take a minute or so for it to come up. And also I've restrained the container by using certain memory limiting the CPU and the memory on the container, so that if it goes above that, it cannot utilize a full host nodes CPU and memory. Okay, I think it'll take a minute more. Let me pause the video for a second till it comes. Okay, it came back up. So that's awesome. And yeah, this is the application that I'm running. And okay, now to get to the wonderful part of our application. So this is the server. So if I see vi server.py, I will see that the cluster node automatically gets pulled into this, and if the and I'm going to increment by container 1, and yeah, that's pretty much it, and it's going to execute this scale cloud command to do that. So, and this is the client has this let me run that. Okay, and on this client too, these are my two worker nodes, right? So I've created both the worker nodes. Now I am running the server nodes. So now I should see the utilization of the container. So now I can see by Cloud App 2 has not sent anything yet, but for Cloud App 1, which is node number 1, this 0.29 is a utilization. Okay, 1 second. Run that one more time. Let me pause the video for a second and see why this is not giving me the yeah, so essentially why I'm just seeing this is because this one is not well, it's not running. The Cloud App is not running on server 2. That is why I'm not seeing it. Let me now execute my stress test so that it will get hopefully spawned on this, and it's essentially Apache benchmark system util I'm using, which will generate around 100,000 and concurrently 1,000 at a time parallelly. So yeah, it's running the benchmark. Let me see if any containers get spawned. The Cloud App container, which is this one, I'm hoping that it would get spawned. Yes, it did get spawned on this. And yeah, so I'll just kill that process. And okay, so because of the two got spawned. Now since I've killed it, now let me look at the server.py. I see that 2 got spawned. It's scaled to 3. Now I am seeing the as it got okay, it got scaled to 4 now. And yeah, 1 2. So on cloud node 3 there's a util. It's on 25%. If you give it a minute or so, it should scale down. Just pause the video for a second till it does. So actually it has scaled down from the high number we saw above here, and it's 3 to 4 to 7 and finally 1. So if I see this, now it has scaled down to this. Yeah, so this is how we have implemented Elastic Container Service on Docker Swarm cluster. Thank you for watching. I hope this was informational.